Hello students, welcome you to this session. In today's class, we are going to start the new lesson, chapter number 2, Basic Algebra. It's one of the very simple topic. So what are the things you study in the lower classes? Everything we are going to recall. Okay, so even the logarithm we are going to see. Okay, so you study in the lower classes, but some of the things you would have forgot. So we are going to recall everything and a lot of sums we are going to do. So we start with number system. You know what are numbers? So the basic one is set of natural number, right? Or counting number. Natural number starts with 1, right? 1, 2, 3, 4, etc. And set of natural numbers we denote it as what? N, right? Set of natural numbers we denote it as N. So natural numbers starts with 1, 1, 2, 3, 4, etc. So with this set, if you add 0 also, that we call it as whole number, right? So W is the whole number. So with natural number, we attach 0 also. 0, 1, 2, 3, 4, etc. So every natural number is a whole number, but whole number is not a natural number because 0 is there, right? So set of natural number is a subset of whole number. Then, if we take the negative values, -1, -2, -3, also along with this, we call it as integers. Set of integers, we denote it as Z. So here 0, 1, 2, 3, etc. Same way in the left side, like number line we write, no? So left side we write -1, -2, -3, etc. So this set we call it as what? Set of integers, okay? Then we have rational numbers. We have rational numbers. You would have studied in the lower class, right? What is a rational number? Numbers of the form P by Q, right? If I ask you to give some example, you will give immediately. But what is the definition of rational number? Numbers of the form P by Q. It's a fraction, right? Numbers of the form P by Q, but that is not enough. Some conditions there. So P and Q are integers. Numbers of the form P by Q, where P and Q are integers. One more condition, Q not equal to 0. Q means the denominator. If the denominator is 0, what happens? Something by 0, it is what? Not defined. Okay, so rational number means numbers of the form P by Q, where P and Q are integers. Numerator one integer, denominator one integer, but denominator is not equal to 0, a non-zero integer. Okay, such numbers we call it as what? Rational numbers, and rational numbers we denote it as Q. Set of rational numbers we denote it as what? Q. Then you know another very important thing, that is real numbers. Real numbers, it is the union of rational and irrational numbers. It is a union of rational and irrational numbers. So you know what are irrational numbers? The numbers which are not rational are called what? Irrational. Suppose you take 7. 7 can be written as 7 by 1. Numerator integer, denominator integer, right? And denominator not equal to 0. So it is a rational number. Suppose 2.15 can be written as 2. You can't say 2.15 by 1, so it is rational. No, because numerator is not integer, 2.15, right? But what you have to do here, 2.15, you can write it as multiply by 100 and divide by 100. 215 by 100, then you can cancel and write. Okay, so it is a rational number only, 2.15. Root 2 is not rational, even though you can write root 2 as root 2 by 1. P by Q form, but it is not a integer, right? It's not an integer. Root 2 is not an integer. 1 is an integer, but root is not integer. So it is not rational, so root 2 is irrational. So the numbers which are not rational are called what? Irrational. If you see the decimal expansion of that, it won't terminate. It's going on. Also, it won't repeat. You would have seen some decimals, say you would have got something 3.333. Sometimes it goes like this, right? So it is not terminating. It's going on, but repeating, right? Recurring. So this is a rational number only. This is a rational number, 3.333, etc. It is non-terminating but recurring. So it is rational. Irrational number means, see, 3.314295623149321, etc. It is non-terminating, but also there is no pattern, right? So it is not recurring. It is not recurring. Okay. So it is not rational, it is irrational. So for irrational number, you can give a lot of examples. Root 2 is irrational. Root 3 is irrational. Later we are going to see the proof of that. Okay. Rational. So these are irrational numbers. Root 2, root 3, root 5, root 7. All these are irrational. Even pi. You may say, sir, pi is 22/7 or 3.14. But that is not the actual value of pi. It is only some approximate value. For our calculation, we are taking that. Okay. So pi is irrational. Pi is irrational. It is a Greek letter. Okay. It is an irrational number. Its approximate value, if you search in Google, you can see. So pi, the approximate value is, it is pi equal to 3.1415926535897993238446. It goes on like this. Okay. So it is non-terminating. Also, it is not recurring. So pi is an irrational number. Suppose they are asking you find the area of a circle, pi r square. You can't put this pi, right? It's very difficult. So we take the approximate value, round it for 2 decimal places. We take 3.14, or we take 22/7. 22/7 is rational. 3.14 is also rational. But actually pi is not rational. Pi is irrational number. But 22/7 and 3.14 are rational numbers. You know the reason for that. Okay. Now, the next what you'd see, you know what are prime numbers, right? Prime numbers and composite numbers. What are prime numbers? Numbers have only 2 factors. 1 and number itself. 5 is prime number because it is divisible by 1 and 5 only. 13 is prime number, right? Like that you can say so many prime numbers. 47. It is divisible by 1 and 47 only. Can you say which is the smallest prime number? Some of you are telling it is 1, right? It is not a prime number. 1 is not a prime. Because prime number means it must have 2 factors. 5 is prime number. The factors are 1 and 5. 3 is prime number. Factors are 1 and 3. 2 is prime number. Factors are 1 and 2. But what about 1? It has only 1 factor. So this 1 is neither prime nor composite. So 1 is not a prime number. The smallest prime number is what? 2. 2 is the smallest prime number, and the only even prime number is what? 2. 2 is the only even prime number. Okay. Now, but that already you know. But I want to teach you coprime. Coprime. So 2 numbers you take. So when can you say they are coprime? Some of you may think both are prime, then it is coprime. No. So what are coprime numbers, you know? You take 2 numbers. See, what are the common factors for that? You find the numbers which divide both the numbers. Suppose I am taking, say, 6 and 8. Both the numbers are divisible by 1. Both the numbers are divisible by 2. Anything else? 3 you can divide 6, but you can't divide 8. 4 you can divide 8, but you can't 6, right? So only these are the 2 common factors. So, but if I take some number, say 8 and 9, what are the common factors? Both the numbers are divisible by 1. 1 is the only one common factor, right? So these type of numbers, we call it as what? Coprime. Suppose you take 3 and 5, or 3 and 8, or even 2 and 5. All these are coprimes. See, 3 and 5. Both the numbers are divisible by, nothing is common, no? So it is divisible by 1 only. 3 and 8. It is divisible by 1 only. 2 and 5. Nothing is common, right? So these numbers are all, we call it as what? Coprime. So coprime means for 2 numbers are said to be coprime if they don't have any common factor. other than 1. So 1 is the only common factor. So need not be the two numbers are prime numbers. So here 8 and 9, 8 is not a prime number, 9 is not a prime number, but 8 and 9 are co-prime because they don't have any common factor other than 1. If I take 3 and 8, 3 is a prime number, 8 is not a prime number, but still 3 and 8 are what? Co-prime. 3 and 5, if you take 3 is prime number, 5 is prime number, 3 and 5 are co-prime also because nothing is common for them except 1, right? And another one type number that I just am telling you, since we study co-prime, another one is called twin prime. Just some extra information for you. Twin prime, so two numbers. Twin prime, both must be prime and the difference must be 2. Two prime numbers whose difference is 2, then we call it as twin prime. That numbers we call it as what? Twin prime. For example, you can take 3 and 5. Are they prime? 3 is prime number, 5 is also prime number. They are twin prime because the difference 5 minus 3, it is what? 2. So they are twin prime. Can you give some other example? Some are telling 5 and 7, right? Yes, 5 and 7 both are prime and the difference is what? 2. Anything else? 11 and 13 you can say 11 and 13 you can say. Even 17 and 19 they are twin prime, right? So twin prime and co-prime are different. Okay, so twin prime, both the numbers are prime numbers and the difference is what? 2. Co-prime means two numbers need not be prime numbers. Two numbers, but for that two numbers, nothing is common other than 1. Even 25 and 27, they are what? They are not twin prime, they are co-prime. Co-prime, because nothing is common for that two. 25 and 27, both the numbers are not divisible by some number, right? Except 1. So, and for co-prime, there are some other names also there. Co-prime, or we call it as relatively prime. Co-prime is also called relatively prime. So some other names also you remember. Relatively prime, or we call it as mutually prime. They are prime to each other, right? Mutually prime. Okay, hope I understood this one. Okay, now listen here. So we discussed rational numbers. So natural number, then you attach 0 with that whole number, then negative number is integer, then rational number, numbers are the form P by Q, right? Rational number. Then we studied irrational number, okay, irrational number. These two together only, we call it as what? Real numbers. So real numbers is the union of two sets. Which two? Rational and irrational. So real numbers we denote R, real numbers. Rational number we denote Q. But for irrational number, we are not using any symbol. For irrational number, we denote it as R minus Q. Why you know? From real numbers, if you remove rational, you will get what? Irrational. Because real number means it has rational and irrational. So from real numbers, if you remove rational numbers, you will get irrational numbers. So for set of irrational numbers, we use the symbol R minus Q. Okay, so these are something important. Next, what I want to teach you is some absolute value, how to find absolute value. That is a modulus value you would have studied in the lower class, right? Modulus x. What is modulus 7? It is 7. What is modulus minus 5? It is plus 5, right? So what is happening here, you know, if the number is positive, you write it as it is. If it is positive, write as it is. If it is negative, it is negative, minus 5. What we are doing, you change the sign. That is, you put another minus in the front. So minus and minus become what? Plus. So if it is positive, you write as it is. If it is negative, you put a minus in front. So that means minus into minus become what? Plus. Okay. So modulus x means it has two values. We write it as x itself. We write it as x itself when if it is positive. When x is positive, greater than or equal to 0, and if x is less than 0, that is if it is negative, you put a minus in front. So your answer is what? Minus of x. So minus 7's modulus means minus of minus 7. So minus minus it become what? Plus. So remember, modulus x has two values, plus x and minus x. Okay. So now listen here. Suppose if we see somewhere, modulus means positive. It is 0 or more than 0 only, modulus value. Okay, it cannot be negative. Suppose if they say somewhere like this, modulus of 5x minus 12 is less than minus 2. See, left side you see, it is modulus of something, right? Modulus of something means it is either 0 or more than 0 only. You can't say it is less than minus 2. So it won't happen, right? So in this case, you have to say there is no solution. You have to say there is no solution. Suppose they are telling, say 5x minus 12. Modulus of 5x minus 12 is greater than minus 4. Modulus of some value, it is 0 or more than that only, right? But what they are telling, it is more than minus 4, definitely, right? Suppose a test is conducted, right? Suppose you are telling how much mark you got. Nobody will ask how many of you scored more than minus 5, right? Because minimum mark will be 0, but you won't score like that. So it is meaningless, right? So everyone scored above minus 4 only, right? So here the modulus value greater than minus 4 means you give any value for x. You give any value. Solve means you have to find x value. So here x you can give any value. Whatever you get, definitely your answer is more than minus 4 only. Okay, because you know absolute value or modulus means it is either 0 or more than 0 only, right? It is either 0 or more than 0 only. So in this case, you say every number is a solution. Every number is a solution. Previous one, he said there is no solution. But here every number is a solution. That means x is equal to R or x belongs to R. Set of real numbers. You can take any number as your answer. Or we say x belongs to minus infinity to plus infinity. X belongs to minus infinity to plus infinity. That means it can take any value. It can take any value. Okay, so here I want to teach you something about intervals. There are two types of intervals. First, once you are thorough with the basics, it will be very, very easy because chapter itself what basic algebra, right? So every time you see, you learn the basics, not only in this topic, every chapter. Once you're thorough with the concepts, then the sums you can do very easily. So what I'm teaching, so try to understand each and every step. Okay, so now please listen. Intervals. We have different types of intervals. One is called open interval. Another one is called closed interval. Listen, what's the meaning of that, you know? First, I'll explain how to denote. Open interval means we denote like this, say 2, 5, open interval. And the closed interval, we use the symbol, for closed interval, we use the symbol square bracket, 2, 5. What's the meaning of that, you know? In the open interval, 2 to 5 means we take values between 2 and 5. So using inequality, how to write, you know, 2 less than x less than 5. And here we write 2 less than or equal to x less than or equal to 5. In 10th standard, you would have studied. If less than or equal to means that number also included, right? So in the closed interval case, the 2 and 5 are included. 2 and 5 are included, but in the other case, 2 and 5 are not included. You can take the numbers between 2 and 5. Don't take 2, don't take 5. Can you tell me which number you can take? You can't take 2. Then what's the next number? You are thinking it is 3, right? No. After 2, what's the next number? It is 3 only. No. Some more number is there. Between 2 and 3, there are so many numbers. 2.5, right? Now, which is the number after 2? Now, you may think it is 2.1, right? Not that. Some more. So after 2, what is the number? Means 2.00001, like that. It is not 5 before 5. Now you know, before 5 means it is not 4, very close to 5, right? Before 5 means 4.9999, like that, right? In the set of natural numbers, if we take, okay, after 2 means it is 3 only. Before 5 means you take what? 4 only, but we are talking about real numbers. We take all the decimals, everything. So we don't know exactly what the number, right? So before 5, it is 4.9999, like that. But in number line, how to denote? Please listen here. So between 2 and 5, say this is a number line, minus infinity to plus infinity. 2 is somewhere here. You mark 2, Say this is 2 and 5 here. So we want the portion between 2 and 5. Between 2 and 5 means you shade like this. The 2 and 5, let it be open. Don't shade that one. Don't darken that one. Okay, that is for open interval. Same thing when you take closed interval, listen carefully, everything same. Minus infinity to plus infinity. Closed interval 2 to 5. So 2 is here and 5 is here. So 2 to 5, between 2 and 5 you take. And one more thing, 2 and 5 are included, right? So that circles also you have to shade. Don't leave it open. Hope you understood the difference. Okay, how to denote the interval, how to denote using what? Symbol, right? Open interval, one bracket, and closed interval, we use another bracket, square bracket. And in number line, how to denote, in inequality, how to denote, okay, that's important. And whenever write infinity, suppose, see, I'm giving something like this. Say 2 is here, here infinity. How can you mark this as an interval? X belongs to 2 is not included. So you cannot write closed interval. You can write only open interval, right? 2 comma infinity. Infinity always you put open interval. Infinity and minus infinity always you use only open interval. Closed interval means that number is included. Infinity you cannot include because we don't know what is infinity. It's a very big number, that's all. Minus infinity means very, very small number. We don't know what it is. So whenever you write infinity or minus infinity, with that you have to use only open interval. Okay. Suppose I am taking something like this. I am shading, say this is minus 5 and here 4. This portion I am shading. Can you tell me which interval this one? Minus 5 is included, right? Because dark turned that. So minus 5 is included. So closed interval minus 5 comma 4. But 4 is not included. So that side it is open interval. Are you able to understand? So if it is included, closed interval. If it is not included, open interval. Okay. So hope you understood all these things. Now just I'm going to give just 2 more results. Then we go for the sums. Listen, suppose if we somewhere, these are all very important things. Modulus of xy, you can write it as, you can split into 2. Modulus x into modulus y. Same way even division, modulus x by y. You can write it as modulus x by modulus y, you can write, provided y is not equal to 0. And modulus x plus y, it is an inequality. Inequality means it is not equal, right? It is unequal. So inequality means here it is less than or equal to modulus x plus modulus y. So multiplication you can split into 2, division you can split into 2, but addition you can split, but you can't put equal. You write less than or equal to. Okay. Now look, just one very, very important result. Modulus x less than r, what's the meaning of this? And modulus x greater than r, what's the meaning of this? So please listen, it's a very, very important thing. So after this, we are going to do few sums. Modulus x less than r means x lies between minus r and plus r. X lies between minus r and plus r. X lies between minus r and plus r. Okay, so minus r less than x less than r. X lies between minus r and plus r. So you can denote like this in the number line. Say minus r and plus r. Say minus r is here, plus r is here. Between, so only this portion will come. Okay, so this is very important. Modulus x less than r. The meaning x lies between minus r and plus r. Another one, modulus x greater than r, meaning x lies outside. X lies outside minus r and plus r. In the first case I said x lies inside, right? X lies inside minus r and plus r. If you want to write it as an interval, you can write open interval minus r plus r, right? But here x lies outside minus r and plus r. So please listen here, you have to do very carefully. Minus infinity to plus infinity, minus r and plus r. Inside means this portion, right? But here x lies outside minus r and plus r. Don't shade that portion. That portion, leave it. Shade the remaining portion. That means you have to shade this portion and you have to shade this portion. So can you tell me as what? As an interval, The first, this is minus infinity to minus r, also r to infinity, both you take union. So this is a portion outside minus r and plus r. So remember, less than means inside, greater than means outside. So if we get somewhere modulus x is less than 10, what's the meaning? X lies inside or between, x lies inside minus 10 and plus 10. How can you denote it? See, minus 10 is here, plus 10 is here, here minus infinity, plus infinity, between, so this portion. Suppose it is less than or equal to, then again you say x lies in between or inside minus 10 plus 10, but minus 10 and plus 10 also included, you have to shade that also. Okay. Suppose modulus x is less than or equal to 4. What's the meaning of that? X lies between minus 4 and plus 4. Minus 4, minus infinity, plus infinity, minus 4 is here, plus 4 is here, between. So this portion, since less than or equal sign is there, that minus 4 and plus 4 also included, so you have to darken that circles. Okay, so how can you write in interval, closed interval, what? Minus 4 comma 4. Okay, hope you understood this. Greater than means outside, leave that, shade the other portion. Okay, so that's all the theory part for today's class. Now the first exercise, very simple one. So just to go through a few sums, look at the first one. See the first question, classify each element of one set given. So you take the first element and you see it is the member of n, q, r minus q, r, then r minus q, then finally what do you have? Z. So what is Z here? Z stands for set of what? Integers, right? Z stands for set of integers. So you have to, first one is n. N stands for what? Set of natural numbers. Set of natural numbers. Then we have q. Q is set of rational numbers, right? So q is set of rational numbers. Then r minus q. What is r minus q? R minus q is from real numbers, we remove rational. So r minus q means irrational number, right? Okay, now we take one by one. The first number is root 7. Root 7, what is that? Irrational, right? So root 7 belongs to r minus q because it is an irrational number. Second one is minus 1 by 4. It is of the form p by q. Both p and q are integers and q not equal to 0. So it is a rational number. It is a rational number q. Then 0. 0 is what? It is not a natural number. Can you say it is a rational number? 0. Can you write 0 as in p by q form? Yes. 0 can be written as 0 by any number. 0 can be written as 0 by 5. By both 0 and 5 are integers and 5 not equal to 0. It is a rational number. So 0 can be taken as a rational number. Also 0 can be taken as an integer. What is integer? 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. So 0 can be taken as rational number. Also it can be taken as what? Integer. Okay. Then what's the next one? 3. So it is 3.14. We take like that. Okay. So we take the number as 3.14. Okay. So 3.14. That is what? 3.14. It is not natural number, it is not integer. Is it rational number? Can you write it as p by q? Don't say 3.14, already we studied that, right? Pi value, 3.14 by 1. No, it is not p by q form. P and q are not integer, but 3.14 can be written as what? 314 by 100. P by q form, both p and q are integers, so you can say it belongs to what? Q, set of rational number. Okay. So then the next one is 4. 4 comes under natural number. 4 belongs to n. 4 belongs to q. 4 is a rational number because 4 can be written as 4 by 1. And 4 is an integer also, right? 4 belongs to z also. It is an integer. So all these 3 you can write. And the last one, 22 by 7. 22 by 7, p by q form. So it is the value of pi. Pi is not rational. Pi is rational, but 22 by 7 is rational, right? So you can say it belongs to Q. Okay, so that's all the first question. Okay, listen here. Root 3 is an irrational number. Like this, they can ask any question. Root 3 is irrational, root 2 is irrational, root 5, root 7, any question they can ask. For everything, the method is same. So try to understand carefully, okay? So the proof is little bit different one. So we have to prove root 3 is irrational. What we are going to do? Vambukuboro. What we say? No, it is rational. We have to prove it is what? Irrational. What we are telling? No, it is rational. Let us see what happens, right? So when you come some contradiction, when you arrive at some contradiction, then you say, sorry, what I assumed is wrong. It is not rational. It is only irrational. Let me tell a different proof. Okay, so please listen very carefully. So we have to prove root 3 is an irrational number. So what we do, if possible, right? If possible, assume root 3 is rational. So we have to prove root 3 is irrational. We are assuming root 3 is what? Rational. You know, rational means it can be written in the form what? P by Q. So we assume root 3 is rational. So root 3 can be written as P by Q. If something is common for P and Q, you cancel and write. Then finally, P and Q, both anything common you cancel, then you see that nothing is common for them. So that we call it as coprime. So P and Q are coprime. What's the meaning? They have no common factor other than 1. Also P and Q are integers, right? P and Q are integers and Q not equal to 0. Another very important thing, P and Q are coprime. Suppose if it is 6 by 8, they are not coprime. You can cancel it, no? 3 and 4. We write it as 3 by 4. So they are in their lowest form, right? So nothing is common other than 1. Okay, so that's the meaning of coprime. Okay, root 3 is P by Q. P and Q have no common factor other than 1. Now we cross multiply, so what do you get? P is equal to root 3Q. Square both sides. P square is equal to 3 into Q square. 3 into something means that number is divisible by 3, right? So P square is 3 into Q square. So this is divisible by 3 because 3 into something. But both are equal, no? So right side is divisible by 3 means left side also divisible by 3. So you can say P square is divisible by 3. P square is divisible by 3. P square is divisible by 3 means P is also divisible by 3. P square is divisible by 3. So P is also divisible by 3. For example, listen, 81 is divisible by 3. What's the square root of that? 9. 9 is also divisible by 3, right? But remember, P is a integer. P is an integer. Don't simply say, sir, 27 is divisible by what? 3. 27 is divisible by 3. But the square root is not divisible by 3, right? So, but the square root is a decimal. So it is not what? It may be an irrational number. So we cannot take that one because P and Q are integers. So P cannot be like that. So remember, P square is divisible by 3. So P is also divisible by 3. So that step I am going to underline. P is divisible by 3, so P can be written as, since P is divisible by 3, P can be written as 3 as a multiple of 3. Because 27 is divisible by 3, so 27 can be written as 3 into 9. 30 is divisible by 3, can be written as 3 into 10, right? 36 is divisible by 3, you can write 3 into 12. A number is divisible by 3 means that can be written as 3 into something, right? So now P is divisible by 3, so P can be written as 3 into some multiple. I'm taking it as M, where M is an integer. Okay, so where M is an integer. So substitute in the first equation, left side P square, that is 3M the whole square, right? 3M the whole square equal to 3Q square. So expand the left side. So 3 square is 9M square equal to 3Q square. 3 table you cancel, you will get 3, right? So 3M square equal to Q square. Now please listen very carefully. 3 into M square, 3 into M square, 3 into something, so divisible by 3. So, okay, so left side is divisible by 3, so right side also divisible by 3. So you are getting Q square is divisible by 3. Same argument. Q square is divisible by 3 means you can say Q is also divisible by 3. Q is divisible by 3. Now please listen, underline this also. Q is divisible by 3. Here P is divisible by 3. So P and Q, both numbers are divisible by what? 3. But what can you say about P and Q? They are co-prime. What's the meaning of co-prime? They have no other common factor except 1. Now there is a common factor 3. Both the numbers are divisible by 3. So we arrived at some contradiction, right? So we cannot accept it. Why this contradiction happens? Because of our wrong assumption. Okay, so our assumption is wrong. So root 2 is not rational. Root 3 is not rational. Root 3 is what? Irrational. Okay, so we write. So which is that means you can say 3 is a common factor, right? 3 is a common factor of both P and Q, which is a contradiction. Which is a contradiction. Therefore, what can you say? Therefore, root 3 is not rational. And we say root 3 is irrational. That is, root 3 is irrational. So just to explain one more time, please listen. We have to prove root 3 is irrational. So what we did? No. Root 3 is what? Rational. Then rational means you can write it as what? In the form P by Q. So root 3 is equal to P by Q. P and Q are integers. Q not equals to everything. Okay. But another important thing you are right. Because for that only you are getting a contradiction. P and Q have no common factor other than 1. In short, you can write it as P and Q are co-prime. Then cross multiply squared. So 3 into Q square. 3 into something divisible by 3. So P square is divisible by 3. So P is divisible by 3. P is divisible by 3 means P can be written as 3 into some integer. 3 into m. Substitute the first equation. So 3m square. 3 into something divisible by 3. So Q square is divisible by 3. Q divisible by 3. Now P is divisible by 3. Q is divisible by 3. That means 3 divides both the numbers. In other words, you can say 3 is a factor of P and Q. Okay, so P and Q have a common factor 3. But actually, P and Q are co-prime. They have no common factor other than 1. But now we are getting, there is a common factor 3. Why it happened? Because our assumption is wrong. What we assumed? Root 3 is rational. It is wrong. So that means root 3 is irrational. It's an entirely different one. So practice well. Write and see 2-3 times. A lot of writing work there. Same way you can practice. Prove that root 2 is irrational. Root 7 is irrational. Root 5 is irrational. Okay, you can practice instead of 3, you are going to write these numbers. Okay, now let's go for the next question. Are there 2 distinct irrational numbers? Question is, can you find 2 irrational numbers such that the difference is irrational? 2 irrational numbers, their difference is rational. First, is it possible? You say yes. Justify, give an example. Okay, 2 irrational numbers you take, 5 plus 3 root 3, one irrational number, and another irrational number I am taking 2 plus 3 root 3, another irrational number. Now you find the difference, right? Difference means you have to subtract 5 plus 3 root 3 minus of 2 plus 3 root 3. You are getting 5 plus 3 root 3 minus 2 minus 3 root 3. So these two get cancelled. So 5 minus 2, you are getting what? 3. 3 is a rational number, right? So here we have taken 2 irrational numbers. This is an irrational number. This is an irrational number. When you take the difference, you are getting a number rational. So is it possible? Yes, it is possible. Okay. So like this, you can give any example. See that the irrational part get cancelled. So for that, when you write, see that irrational part, you are writing same numbers. So when you subtract that cancel, you will get the real part. Okay, see the next question. Find 2 irrational numbers. Again, listen to the question very carefully. Find 2 irrational numbers such that their sum, now we have to add it. Sum is rational number. So take irrational number, when you add it must get cancelled. That means irrational part, same number you take but different sign. If I take minus root 3, you take plus root 3. So when you add, it will get cancelled, right? So I'm taking two numbers. Can you find, okay, that is the second part. First part, they didn't ask yes or no. So straight away you find two irrational number. Their sum is rational, okay? So I'm taking 5 plus root 3 and 5 minus root 3. Or instead of 5, you take 15, any number you take, right? Are irrational numbers. So two irrational numbers we have taken. Now we find their sum. So sum means you just add it. 5 plus root 3 plus 15 minus root 3. These two get cancelled. So 5 plus 15, it is 20, which is rational. So find two irrational numbers whose sum is rational. Okay. So now we see, just once you understood, you can do it. Okay. So no need to mark up anything. You can give any example. Can you find two irrational number? Again, can you find two irrational number whose product is rational? Product is rational. What is the simple thing you remember? A plus B into A minus B. What is A plus B into A minus B? A square minus B square. What is root 5 square? Root 5 into root 5. So it is what? 5. So with this idea, you can say very easily, 5 plus root 3, 5 plus root 3 and 5 minus root 3 are two irrational numbers. 5 plus root 3 and 5 minus root 3 are two irrational numbers. So now you find the product. Product is 5 plus root 3 into 5 minus root 3. So this is A plus B into A minus B. So A square minus B square. 5 square is 25 minus root 3 square is 3. You are getting 22, which is rational, right? So can you find, they asked. So yes, your answer is what? Yes, we can find the number. You can write it as a sentence. Yes, we can find two irrational numbers whose product is rational. So we given an example also. Okay, so now let us see the last question in this exercise. Find a positive number smaller than this. So please listen here. 1 means 1 by 1, right? 1 by 1. So no, you know it is 1, right? If I take 1 by 2, it is 0.5. The value is decreasing, right? If I take 1 by 4, it is 0.25. If I take 1 by 10, it is 0.1, right? 0.1. So if I increase the denominator, numerator just I am writing as it is. Denominator, if I increase, the value decreases, right? Suppose I am writing 1 by 100. Again reduce, right? 0.01. So if I want to get a smaller number, so I can increase the denominator. So here find a positive number smaller than this. So we have to find a number smaller than this. Very, very simple. Denominator 2 raised to what they return? 1000 they return. What do you do? I asked you to increase, right? 1000 they return. You write 1005. Or 2000 you write. Or 1 by 2 raised to 1000. You put plus 20 you write. Whatever it is, denominator should be increased. That's all. Numerator right as it should be, it is a positive value. So you can give any example. Okay, so hope you understood all these things. But main thing, prove that root 3 is irrational or root 2 is irrational. That proof you study. And the theory part, today I taught more theory part only. Even for the next exercise theory part also I finished. So in my next video, straight away I am going to teach the second exercise. So you go through the inequalities, the intervals and all I taught, right? We didn't do any sum based on that. The next class we'll continue that.